All right, another type of inverse function is inverse trig functions. Here they want us to differentiate or find the derivative of inverse sine of x. Note that some textbooks, as you get older, may refer to this as arc sine of x. Arc sine of x is the same as inverse sine of x. The reason that this notation starts getting used more in upper level math is because do we know that this means inverse sine of x, or does it mean sine x of something to the negative first power, which would have the same notation? So don't be surprised if you start seeing that arc sine of x more. But here it's listed at inverse, we'll go with that. So to differentiate that, what we have to do is change it, change what this looks like. If we have that y equals inverse sine of x, that also means that if we move that sign back to the other side, that x would then be equal to the sine of y. And that is something we know how to take the derivative of. So what we're going to do now is take the derivative of both sides. The derivative of the left side would be cosine of y, but it's a y one, so we got to include the derivative here, dy dx. The derivative of the right side is easy, that's just 1. So now let's solve for our derivative. That our derivative here is equal to 1 over cosine y. The problem here, we don't want to leave our answer with a y. Since we started with something that said y equals x, we'd like our derivative then to be in terms of x, not in terms of y. So can we get there somehow? Well, what you're going to do to do that is draw out a triangle and see if we can figure out what this means. Because if we have this statement over here, we should be able to draw a triangle out that kind of shows what's going on here. So let's draw a right triangle, because remember, trig always is from right triangles. Our angle in this statement is y here. So I'm going to put angle y there. I could have put it at the other one. It doesn't really matter. And then what we want to do is put this other stuff. So if we have that sine of y equals x, what two sides of a triangle do you use when you have sine? Well, sine is opposite over hypotenuse. So our opposite over hypotenuse here then should equal x over, and I mean, we should really have something on the bottom here, so let's think of it as x over 1. So that means on this statement, our opposite should be x, our hypotenuse should be 1. So I'm going to go over and put those things on our picture over here to help us out. So opposite from our angle would be here, hypotenuse would be 1. So now if we did sine of y, it would equal x over 1. Okay, well, what does that mean our other side down here is? We could get that by doing Pythagorean theorem. If we did our two shorter legs squared here, so I'm just going to call one of them a squared plus b squared equals c squared. Our Pythagorean theorem, we'd have a squared plus x squared equals our hypotenuse squared, which is 1. So solving that for a now would be 1 squared is 1, so 1 minus x squared. And then to finish it, we take the square root. And really it should be plus or minus, but we're doing distances here, so it's only the positive one. So that means this third side of this triangle here is square root of 1 minus x squared. Okay, so now we should be able to finish this derivative here. Our derivative is equal to 1 over cosine of y. What would cosine of y be equal to here? Well, cosine uses the adjacent side over the hypotenuse. And so if we wrote that out, that would be square root of 1 minus x squared over 1. Well, we don't need to write that over 1 part because anything over 1 is just itself. So our derivative then is this. The derivative of inverse sine ends up being 1 over the square root of 1 minus x squared. All right, once you pause the video and try this one out, see if you can differentiate inverse tangent x. All right, let's see how you did here. So like the last problem, let's move that over. So that gives us the statement x equals tangent y. Now let's differentiate. Let's find the derivative. Derivative of the right side is 1. Derivative of the other side is secant squared y. Oh, sorry, I forgot the dy dx, so let's get that in there. Secant squared y, because we're doing derivative of y, so we got to have the derivative in there. And then let's solve for our derivative. Derivative equals 1 over secant squared y. All right, so now let's try to get our answer in terms of y. So if we draw out a triangle with our stuff here, our angles y, tangent uses opposite over adjacent. So our opposite side should be x, and our adjacent side then should be 1 because we want it to equal x, x over 1 or just x. What's the hypotenuse there? Use the Pythagorean theorem again to find it. So we'd have 1 squared plus x squared equals c squared. To solve that, just take square root. So it'd be 1 plus x squared. So that's our third side here. That this is 1 plus x squared. Sorry, square root of that. Square root of 1 plus x squared. All right, so for our derivative now, we got 1 over secant squared. What's secant use? Well, secant, remember, is the same as secant is equal to 1 over cosine. Cosine, or it's a reciprocal of that. Cosine uses adjacent over hypotenuse, and so secant would use hypotenuse over adjacent. So we want to write this as our hypotenuse over our adjacent here. So our derivative would be our hypotenuse, which is right here, so square root 1 plus x squared, over our adjacent, which is 1. And then remember here, this was secant squared. So we just substitute in what secant would be equal to. We got to square that because it's being squared there. So what's our derivative going to equal then? Well, again, it's over 1. We don't need to write that. If you square root of 1 plus x squared, it'd just be 1 plus x squared. So that would be the derivative of inverse tangent. Here's the other inverse ones. You can see here was the one we just did. There was the one we did in the first one. The remaining inverse ones are here. Notice that some of these are very similar to each other, like sine and cosine. Here are opposites. The only, or they're similar. The only thing difference is that little negative sign. These two are similar. The only difference is, again, the negative sign. And then these two are similar again with the negative sign there. So just some things to notice when you're doing inverse ones.